Example: find the absolute maximum means find the greatest value of the function, and absolute minimum over the specified interval and state where those points occur. Okay, f of x is equal to x square minus 3 into x power 2 by 3, and this is the closed interval 0 comma 2. Okay, so let's start the solution. And this is our given function, and we know that our first step is we find the value of the function at the end point of the interval. So first we find the value of the function at x is equal to 0, and then we find the value of the function at x is equal to 2. So first step is evaluate f at the end points x is equal to 0 and x is equal to 2, and the value of the function at x is equal to 0 is 0, and at x is equal to 2 the value of the function is approximately equal to minus 0.7622. Okay, next step we find all critical value of the function, and then we evaluate value of the function at those critical points. So step 2 is find all critical points of that function lies over the interval. Okay, this is open interval, and evaluate f at those critical points. So the first we find the derivative of the function, and this is the derivative of the function. Okay, so next we have some key points. We can see that if x is equal to 0, the derivative of the function is undefined at x is equal to 0, and for x is not equal to 0, the derivative of the function is 0. So now we substitute put over here f prime of x is equal to 0, and then we find the critical value. Okay, so put f prime of x is equal to 0, and after substituting f prime of x is equal to 0, we get two critical values, x is equal to 1 and x is equal to minus 1. Okay, so therefore the critical points are x is equal to 0, minus 1 and 1. Okay, and at x is equal to 0 we know that the derivative of the function is undefined, and this is also our critical point. We have already discussed in previous videos about critical points, how to calculate the critical points. Okay, and so I will provide the link in video description. Okay, so x is equal to minus 1 is not in the interval. Our given interval is 0 and 1, so minus 1 not belongs to our given interval. Its mean x is equal to minus 1 is we will not take this critical point. We take only x is equal to 0 and x is equal to 1. Okay, so next step we have we compare all values found in step 1 and step 2. Okay, and this is the column for values of x, and this is the value column for values of the function at x, and this is the conclusion of the function. Okay, so at x is equal to 0, the value of the function is 0, and at x is equal to 1, this is our critical point, the value of the function is minus 2, and at x is equal to 2, the value of the function is approximately minus 0.7622. So we can see that at x is equal to 0 we have absolute maximum, means that this is the greatest value in the interval, greatest value of the function in the given interval, and at x is equal to 1 we have the value of the function is a minus 2, and this is the smallest value. Okay, smallest value. Okay, in given interval. So this is our minimum, absolute minimum. Okay, so we conclude that absolute maximum of the function over the interval is 0. Okay, and it occur at x is equal to 0. Absolute maximum is 0 and it occur at x is equal to 0. Okay, next the absolute minimum is a -2 and it occur at x is equal to 1. Okay, absolute minimum and it occur at x is equal to 1. So we can see that with the help of graph. So let's check. This is the graph of the given function, and at this point we have an absolute maximum, that it at x is equal to 0. The value of the function at 0 is 0. This is our absolute maximum. This is the greatest value. Okay, and greatest value, and this is our absolute minimum. This is the smallest value at x is equal to 1. The value of the function at 1 is -2. This is the smallest value of the function. We can say that this is global minimum and this is the global maximum.